Hi, it's time for the math. Easy solution to discuss further into infinite limits at infinity and look at a second part of the examples series, basically over these two useful examples. And the first example I'm going to go over is this one right here, which says, example 1, limit as x approaches infinity of x squared minus x all divided by 3 minus x, right? And now to solve this limit, well, we could either use L'Hopital's rule, because the top and bottom is going to be infinity divided by infinity, or simpler method, divide by the highest power. I've done this in my earlier examples on limits at infinity, horizontal asymptotes videos, but I forgot to mention in the denominator. So you only look at the highest power in the denominator. In this case, x squared is the highest power overall, but that's in the numerator on top. So you look at the highest power, which is just x right here. So you would multiply the top and bottom by, or divide the top and bottom by x. So 1 divided by x multiplying the top, and at the bottom, so we're not affecting the equation because these just cancel, equals to 1. So if we multiply these inside here, we're gonna get over here limit as x approaches infinity of, well, x squared divided by x minus x over x, and then 3 over x minus x over x, and this simplifies to limit as x approaches infinity of, this one's going to be x minus 1 all divided by 3x minus 1 right here. So now if you were to put really large numbers in here, as you can see, well, the top's going to be going to infinity, so because you're going to have infinity minus 1, so this is going to infinity, but the bottom right here, well, if you look at this one right here, this part right here, 3 divided by x, this is going to, well, 0 as you divide by really large number. 3 divided by infinity, etc., you're going to 0. So the bottom overall is just going to be approaching -1 right here. So yeah, it's just approaching -1. So you're going to have now an infinity divided by a -1, or a really large number divided by -1. So you'll always be approaching infinity, but from the negative side. So we get our limit as x approaches infinity of x squared minus x all divided by, what is this, 3 minus x equals to -infinity. So we just highlight that. Yeah, now I'm going to go over example 2, which basically states sketch the graph of y equals x minus 2, this is to the power of 4 times x plus 1 all to the power of 3, and then times by x minus 1, and then to basically sketch this by finding its intercepts and its limits as x approaches infinity and as x approaches -infinity. So basically it's saying just roughly sketch this with basically finding the infinite limits at, the limits at infinity, which assume there's going to be infinite, and also its intercept. So the first thing we should do, let's look at the y-intercept, and remember the y-intercept, what this is basically when x is equal to 0. So when x is equal to 0, so we basically find when y of basically what values of basically what y value is when x 0, y of 0, or f of 0 right here. So we just basically set x to equal to 0 and find for y. So we're going to get y is equal to, well, -2. If we put a 0 there, to the power of 4 times 0 plus 1, this is going to be 1, 3, and then 0 minus 1 is just be like something like this right here. So 1 cubed is just 1, this is going to be -1, just -1, and then -2 to the power of 4 is equal to, well, this part's going to equal to positive 16. So etc., we're going to have now plus 16 times it by 1 times by -1, so as etc., we're going to get -16. So this is the y-intercept. So now to find the x-intercept, or the x-intercepts right here, these are basically whenever y is equal to 0. So that's what we can do. We could just set y is equal to 0. So we're going to have x, what is this one? X minus 2 to the power of 4 times it by x plus 1 to the power of 3 times by x minus 1. So now this is 0 when, well, when any of these are 0, because they're multiplying, it's going to be 0. So basically the x-intercepts are going to be, well, when this part is 0, and this is when x equals to 2, and when this is 0, this is when x equals to -1, because -1 plus 1 is 0. So -1, and then this side right here is at x is equal to 1. And I'll just put this in a box like this one right now. So now let's look at the limit as x approaches infinity of the let's just call it f of x right here. So when we look at this function, this is basically this one right here. As you put larger numbers in this this quadrant, I mean this to the power of 4 function, you gotta have infinity to the power of 4. It's gonna be infinity. And this is also going to be infinity. So every single one of these is going to infinity. You're just putting really large numbers inside here. So this is just infinity. So now if you look at as x approaches to negative infinity in this case of f of x. So if we just look at this one for reference, this part right here, as you're approaching negative infinity, here you're going to get a negative infinity to the power of 4. Remember, anything to do with an even power, you're going to become positive. So it's going to be well equal to plus infinity. So, or just say plus, let's just put it like, just an arrow here doesn't really equal that. So just basically, it's going to be a plus infinity times it by, well, this is this is to the cube. So now you're going to have a negative infinity to the power of a cube or an odd powered function. So you're going to be really, really large, but negative. So it's going to be something like times by negative infinity, and then similar to this one, you're just going to have to negative infinity right here, minus 1, still going to be negative infinity. So we're going to have negative infinity right here. So we're going to have a really large number of times it by two really negative numbers, but negatives of each one. So remember, two negatives make a positive, so the negatives cancel, and we're going to be left with, well, just positive infinity. And we'll just write that down right here. Limit as x approaches, I'll put negative right here. Negative infinity is equal to of f of x equal to positive infinity. Yeah, so now if we put it all together, we're going to have a y-intercept here, negative 16. And now we have these negative 1, 1, and 2 intercepts, x-intercepts. So this as a value at here, and we know that at infinity it's going to go to positive infinity. And then at negative infinity, it's going to go, well, to positive infinity as well. So we'll just draw something like that. So it's going upwards. And now notice that this function right here, the x minus 2 all to the 4, if you have somewhere close to it, because this is always positive, so if you had something like, let's say 1.9 minus, yeah, so if we had x equals to 1.9, if this is x, so 1.9 minus 2 equal to, well, negative 0.1. And then to the power of 4, remember this is going to be greater than 0, but it's going close to 0. So it's greater than 0, and if you had 2.1 minus 2, this is going to be, well, 0.14. This is also greater than 0. So what I'm saying is that this never crosses the x, yeah, so it never crosses this intersect. So we don't go down this one. So it's because the close to it's still going to be positive. So it's going to be something like this. And then we're going to have an intercept right here. And these always cross here on these ones because of this this odd function right here. For example, yeah, this one's going to be power of 1, still an odd function, because if you had something like 0.9 minus 1, this is going to be negative, well, yeah, this is going to be negative 0.1, and yeah, this is going to be less than 0, and we have 1.1 minus 1, this equals to 0.1 is greater than 0. So as you can see, it crosses the x-axis, because these ones aren't going to be changing too much. Yeah, they are not going to be changing too much when you're just going really small numbers here, close to this x equals to 1 here. So all I'm trying to say is that it crosses here. Similarly for the basically at x equals to negative 1. So it crosses like this, it goes down, touches to this, then goes back up. And as you can see, this is how the function kind of looks like right here. So yeah, this is just a rough sketch to show that you could find how a graph looks like just by intercepts and infinite limits. Yeah, and now I've actually graphed this with Google just to see how accurate I was in this rough sketch. This is pretty rough right here, but as you can see, it's pretty much the same thing. It's just a bit lower here than this one, and this is the same thing. There's intercepts right here, negative 1, 1, 2, and also this is at a negative 16. As you can see, it goes to infinity here as you go negative infinity, and then as you go positive infinity, and it goes to infinity as you go negative infinity. Well, that's all for today. Hope you learned from these two useful examples. Remember, you can always download these notes in the Dropbox link below. Hopefully you enjoyed, and stay tuned for another math easy solution.